Lately I've been thinking about the configuration interface for a dpedal, the open source foot pedal I'm working on. Currently I have a custom command line flashing tool that writes the bytes of the firmware and the config to the device in a single operation. I adore this approach since it ensures that the flashing tool, configuration and firmware are all compatible before anything is written to the device. And for a technical user, a config file is ideal since the state is stored on disk and can be easily tweaked and reflashed in the future. But this approach relies on the user being somewhat technical, which is fine when I'm the only user, but I want to make dpedal accessible to more people. So now I'm thinking about alternatives. What I want is a new tool that 1. Has a GUI, 2. Retrieves current config from the device, not a config file, and 3. Is trivial to install. To make this truly easy to install, I'm thinking of providing a web interface through which users can configure the device. No installation is always the easiest installation. I'll have the address for this web page printed on an exposed part of dpedal circuit board. During manufacturing of circuit boards, in a process called silk screening, a layer of text and graphics is drawn onto the board, usually to indicate where components should be placed. However, I can make use of this silk screen as a cheap way to include text on the dpedal. Including the web address on the device means anyone hands-on with it can figure out how to configure it if they know how to use a web browser. There is only one problem with this. The webUSB standard, the one I need to talk to arbitrary USB devices, has very poor support across browsers. Currently it supports only Chrome, and has no signs of support reaching other browsers anytime soon. But I've seen a demonstration where a USB device can send arbitrary data between a web page on all major browsers, regardless of their webUSB support. The demonstration titled, "I Can't Believe It's Not WebUSB," was made by GitHub user Arcane Nibble 3 months ago. The secret? Have the device pretend to be a hardware security key. A security key is used in some two-factor authentication schemes to better secure logging into websites. These security keys use the FIDO protocol to talk to your web browser. We can use this FIDO protocol, which all browsers support, but instead of sending the key handles and signatures used for two-factor authentication, we will smuggle in our own data in those same fields. The original demonstration is written in C and runs on a Raspberry Pi Pico. Since dpedal uses Rust, I'm going to port the demo to Rust to better understand how this trick works and what its limitations are. I've made some progress with the Rust implementation. I've been blinking the LED on my Pico to check that I'm on the happy path. If it stops blinking, I know my firmware crashed. But things are starting to get complicated, so I really ought to bring out a debugger. I have a Glasgow interface explorer lying around that I haven't had an opportunity to use yet. While the Glasgow can be used to talk many different low-level protocols, the maintainer recently added support for using it as a debugger. So let's give it a go. After reading the documentation, it looks like I need to hook up the Glasgow to my Pico, like this. That's not very helpful. How about like this? My computer is connected to the Glasgow over USB. Then the Glasgow is connected to the Pico over its debug interface. The debug interface uses 3 pins: SW clock, SWDIO, and ground. I connect these to the documented pins of the Glasgow. Additionally, the Pico is connected to the computer over USB for power and FIDO communication. Then it looks like I need to run the command glasgow run probe rs to configure Glasgow as a debugger. And then I can run probe rs info with Glasgow specified as a probe. And success! I can see here that the Pico is showing up as being debugged. Next I need to configure a cargo to run the project via probe rs. Then I set up the project to use dformat. And then finally I sprinkle around some dformat logs. And now with a simple cargo run, my firmware is flash and I'm getting back these beautiful logs straight from the device. People usually think of debuggers as tools for stepping through lines of executing code. And while that can be useful, all I really want here is logs. Armed with these logs, I quickly found out what's wrong with my firmware, and it runs far enough along that the web page from the demo is sending over bytes to my device. Look at this bit logged by the device, which is set by the web page's on-off buttons. Isn't that cool? Now I'm trying to build my own demo. This demo sends text to the device, which applies the ROT13 substitution cipher and sends it back. This proves that I can send large amounts of data between the device and web page. I also built this demo with a slider on the web page that controls the rate of flashing of the Pico's LED. This proves that making lights flash makes my brain happy. It also works on mobile, which I wasn't expecting. Did you know you can connect a wired mouse to your phone?
What?
Anyway, here's a really cool thing I realized late in development. When planning the web configurator, I thought I would have to heavily restrict what it can do. After all, if any website could set macros on dpedal, imagine what evil it could get up to. However, I realized that I can lock the firmware to only accept FIDO requests from my website. This works because browsers include a hash of the website domain in the request, and FIDO is only supported on HTTPS sites. So if we check this hash against the expected hash, we'll know for sure that the website that sent the request is the real one. Now I'm pulling the general logic out of these demos and into a library. This will allow me to use it from dpedal and allow others to use it for configuration or whatever else they come up with. I've named the library Not-webusb in reference to the original demo I found, and it's available on GitHub and published to crates.io with links in the description. Since dpedal is built on top of the widespread USB device library, any firmware also using USB device can easily pull in Not-webusb for configuration. However, there are still a few issues with Not-webusb. First off, the use your security key alert will be confusing for users, since they are configuring a pedal, not a security key. But I think some text on the web page preparing users for this should be enough, and I can always use a proper WebUSB solution for browsers that support it. Also, while Not-webusb seems to be robust on most browsers, I still have some issues on Safari where the browser hangs, but with enough time, I should be able to solve that. So at this point, it seems likely I'll be using Not-webusb for version 3 of dpedal. In a future video, I'll be implementing the firmware and the configuration page, so subscribe if you want to see that. And thanks for watching.